forget what it is. Which one do I do? Do I go from the middle?
No, you just
You
click.
can just like click a
target.
point, yeah.
Yeah, I was gonna say, in tech they did something crazy there.
Yeah, they did it from,
And
yeah.
it took like 8 years for it.
Carry took forever. Carry is a special breed. Takes a while.
Yeah, I'm sorry.
Oh, sorry.
Do you want copies of any of these worksheets?
Huh?
Do you want copies of, I have an extra copy of all the things I'm handing out.
Oh yeah, please.
Yeah. Okay. There's that one. I'll just give you this one for now. I'm not doing anything with it yet. Except I only have 4 pairs of scissors. Oh, I don't need to.
Yeah.
What?
Debrief us on what we know. Is that the same number?
Oh, yeah. So what
Yeah, 2 minutes for your setup.
setup?
Yeah.
I mean, this is a very basic intro thing, so it's probably the first lesson I would consider going over, because I will, like in the objective it says, you're going to learn the parent function of the exponential functions. So that'll be, you'll learn that, so it's probably going to be the first thing you do in the unit. And then we'll just kind of talk about exponential growth and decay. We'll talk about, within the parent function, we'll talk about the parts of it. And we will talk about, and then we'll use that to apply it to data, to this activity, and to the activity that we do. And then prior knowledge, you're going to want to know how to recognize patterns, I guess, and how to know, see how numbers and data is changing from one instance to another, see how it changes over time. And so kind of, yeah, just noticing patterns. I'm trying to think. Yeah, I don't know. That's kind of, I don't have a whole lot to add in. So,
Yeah, now 5:24. So yeah, if you spend 50 minutes, I will call.
okay.
Yeah, please start.
All right.
Yeah.
All right, so welcome to class, guys. As you can see up here, we're going to be talking about exponential functions today. I have provided you with our objectives and goals today, so we're going to go over the exponential parent function. We're going to use that and apply it to data using a fun little activity. Well, I think it's a fun little activity that we'll do. And then we're going to look at equations and graphs after a while to see whether or not data is growing exponentially, or whether it's growing or decaying exponentially. So just for a startup, just to try and get this, get you guys thinking a little bit. I have like a warm-up kind of question here. It says, Sally starts a rumor, or she decides she's going to start a rumor at 8 o'clock. Okay, so she tells, after an hour, she tells 2 of her friends. So at 9 o'clock, she tells 2 of her friends. And every hour after that, everybody that's heard it tells 2 more people. So the people that Sally's friends tell, or each one of Sally's friends that she tells, are going to tell 2 more people. Okay? So if the pattern continues, how many people would be told the rumor at noon. So go ahead and just maybe talk to the person next to you. No.
Okay.
Well, actually, yeah, you can write down different ways you want to do that on there. Because it won't matter what's on there anyway. But we'll use that piece of paper later too, so don't get rid of it.
So she starts her rumors.
Eight.
She tells
Really, really, that's.
crazy much happened before school. Okay, so she tells two of her friends after an hour. So like, it starts at zero.
She tells two, and then
Yeah.
then she tells,
Maybe we can set up a little.
right, so then,
Each one of her friends tells two of their friends after another hour. So
does she keep telling her real?
No, she's not. She does not keep telling the rumor. I should have pointed that out.
Okay.
She stops. Everyone,
Each of them tells.
after they only tell
Then you get-
two people. After they tell the two people, then they're done, if that makes any sense.
But like,
Yeah,
Yeah.
each
And
person's
then,
like one,
is
two,
the
three, four,
question
so
at the end, is it
five,
asking how many people
10,
know the rumor, or is
6,
it asking?
11, it's-
No, that's a good question. It's asking how many people were told at that one time.
That's
At,
what I mean.
at the,
So
on the
after-
fourth hour,
Ten,
at the
there's
fourth
two
hour,
people.
how many people are being told?
Okay,
And
okay.
then like one person tells two
Yeah.
people, and
so
then
then
one
this
person
is
tells two
four.
people. So it's like 1, 2,
And then
3,
this is
4, and then you get
eight.
rid of them too.
Because it's 10 o'clock,
Right.
11 o'clock, 12
Is that
o'clock,
okay?
16 people.
That's how many people know the rumor, right?
That's-
Like, you know what I'm saying? Or,
Oh, yeah.
'cause it's- yeah.
Is that how many people know the rumor, or how many people told the rumor?
It's how many people, that's a good question though. It's how many people were told the rumor at at noon. So it's not how many people know, how many total people know it, it's just how many people were told at that one given time.
Let's see.
So maybe take, I don't know, 30 seconds to a minute to finish up an answer, and we will come back together and
Yeah, we need to go through it.
come up with something.
Yeah, so, like,
Wait.
one person will tell us, like, she's supposed to be one person, it's supposed to be one person, so 6.
Yes.
That's 16.
16.
I like your method. Because you could just go like this, if you start with two, and that person tells, each of those people tells two, each of these people tells two, each of these people tells two, and then each of these people tells two. And then you can just like add them up. Yeah. 16.
Alright, looks like you guys are getting an answer for that. So does anybody want to kind of just walk me through how they came up with their answer or what they were thinking as they went along?
I can go.
Steven?
Yeah, I figured out a way. I kind of did like a little like, kind of like a little branch method. So
Okay,
it's like
tree
this-
diagram.
yeah, true diagram. That's it. So it's like you start with 2, but then like each line would be like a person.
So you make two, okay.
Yeah,
So
so-
one line, okay, so you had something
So
like,
if I, yeah, if you want.
so you had maybe, I don't know, S for Sally.
Yeah, and then
So she, at, let's say, this is time, maybe 1 or 8 o'clock, something like that. Oh, yeah, maybe I'll do that. 8 o'clock, that's better. So at 8, Sally knows it. She's the only one. But now at 9, right, she tells 2 of her friends, so there's 1, and there's another. So we have F and F. Okay, that's good. Now, so then you just kept doing that every hour?
Mm-hmm.
Kind
Yeah,
of
pretty
thing.
much like each
So it's
person
like
would tell
that.
2,
And then,
and then I just counted up the column.
okay, so you're getting. That's gonna get really big.
Yeah, really great job.
Yeah.
Yeah.
I'll get there. Alright. So we have another from there. I'm gonna move this down actually. Stay here. So we have. Alright, so Does everybody make sense? You see what I'm putting F's for like friends? Just very simple kind of notation. All right. There. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. All right. So this is at time 11 right here. Okay. So I'll skip the last step. I'll skip writing it out because you'll see that you have those are F's. Alright, so we have 8 F's there, 8 friends that were just told at 11 o'clock. And you know that this pattern is going to keep going the whole way. Okay? So that means at 11, so these 8 people, when it comes to be 12 o'clock, they're going to have told 2 people each, which is going to give us how many people at the end? 16, very good. And yeah, so that's very good, easy way to do it. That's the good. That's the way I would have done it was with using that tree diagram. Did you guys have any other method of doing it? Just kind of
We just listed them out.
just listen around, talk through it. That's fine too. That's good. All right, we're good. So that's just kind of something to get your mind thinking of how things are going to be. How this number of people being told is going to grow over time. Okay. So now we'll jump into the parent function of exponential functions, which is in the form y equals a b to the x. Okay. I don't know why that's so small, but it is. So the variable a right here is the initial value of our situation or problem. Of whether you start with, in the last example, with the rumor problem, the initial value was just 1, right? Because Sally was the only one that knew it right at the beginning. And now the variable b represents the growth or decay factor. So that means it's the number that it's going up by every time, or going down by every time over time as x increases, things like that. And x obviously is your exponent that you're raising your growth or decay factor to. So if we're talking about exponential growth and decay, when it's exponential growth, this b value is going to be greater than 1, any number greater than 1. Okay? And exponential decay is going to be anything between 0 and 1. So you're kind of any fraction that's less than 1, like 2/3 or 3/4, that'll fit into exponential decay. Yes, Hillary?
Is b over just 1?
B can be 1. But then we kind of have, we don't, in the case that b is 1, you don't really have an exponential function in that case. You just kind of have a constant function where it's staying at that, whether you're, depending on what your initial value is, you'll just be multiplying it by 1. It's going to stay that initial value the whole time. So that's a good question. So like I said, in the warm-up question, our equation, if we turn that in, plugged in numbers there, our initial value, which is a here, we can plug that in as 1, because Sally at the beginning was the only one that knew that at the beginning of the whole situation. And since we know that as time goes on by every hour, the person that was told, people that were told the hour before, tell 2 more people, we know that it's going up by 2, right? The number's going up by 2. If you kind of probably look at your tables there, or if you guys just look at the way you wrote it out, you can kind of see that your numbers are doubling every time. They're going up by a factor of 2, right? Okay? So if we think about this, is this representing an exponential growth function or an exponential decay function? Growth, right? Yeah, because 2 is greater than 1, so that means obviously
You
that's
just can't have
exponential
negative
growth.
rumors.
You can't graph what?
You can't have negative rumors.
That's right. You can't tell negative people. You can't have a negative person, so you can't say, oh, well, negative people know this rumor, because that's not possible. Right? Very good. Yes, good point to make. Okay? So now we're going to do a little activity using the paper you guys have. You don't have to erase anything, but what's going to happen is I'm going to give you this sheet, and what you'll do is just kind of read the directions first, so you know what you're doing, and then you can work together with like the person next to you, or you can work alone. Doesn't really matter. I would suggest doing it with a partner. I made a little bit of a note on the paper here. Just one of those things. To make sure you know that, how we're treating the numbers here. But you'll go ahead and, after each trial, I'll quickly go over the task or the procedure with you. But what you'll do is you're gonna cut your piece of paper, that blank one that you have, you're gonna cut it in half 5 times, but after every time you cut it, you're gonna fill in the table with how many total pieces you have, and how many total, or what the area of your one piece is. And that note that I put in there, it says the dimensions of your sheet of paper, we're gonna call 12 inches by 8 inches, okay? To make our numbers a little bit easier. Okay, so go ahead and work through that. If you have questions, let me know. There's scissors there for you. And it's okay if it's not exact, but pretend that, even if your cutting's not exact, pretend that it is. And then we'll come together after 10 minutes or so to figure it out.
Yeah, we should. Does it matter should we pull it first?
No,
Yeah, hot dog and hamburger.
Should we do
Doesn't matter
different
which one.
ways?
What?
Should we do different ways? Yours or yours?
yes, yes.
Just a
So
few
we have 2 pieces.
previous one.
Area
Yeah.
of 1 piece. If we, well, we probably have to make some 4 by 12.
There's
No,
not a, there should
That's what we're doing.
be, right?
Yes, that should be. Thank you for pointing that out. Yes.
What?
And
Yeah, if you guys want to take a look up here for a minute, I was just notified of this. I kind of might have tricked you with this notation here. Exponential growth and decay is going to be solely based on this B value here. This should be B there.
Okay.
So B should be the one that determines exponential growth and decay. But thank you, Jim, for pointing that out.
I just wonder what happens when b equals 0 or
When
negative
B equals
number.
0?
Or negative number, because there's nothing about negative numbers.
Okay.
Yeah.
Okay.
Why we have to consider the positive numbers?
Yeah.
in
So
the-
let's come back to that
Okay.
after we finish up this activity.
Okay.
Yeah,
Should
Kelly?
we do it to both sides, so if I cut it in half? Do
Um,
I just cut this one in half, or do I cut both of them?
You'll just cut one in half.
Okay, so I'm done with this.
Yeah, once you cut it in half, you're done with the,
Okay.
just note like the bigger pieces. You'll have 2 separate things there, and you'll just keep.
Well, if you
I've
cut
kinda noticed
it,
it.
then like, you cut one over there,
Okay,
so like
so
this, so 6 by.
Well, then don't I
or
always
12
get
by
2?
8. So like this
Pieces
is, it'd be like 6 by.
It says,
right?
no,
Sorry.
number of total
Yours-
pieces, so
yours is
do I
12
have
by
3
4.
pieces now, or
Right.
do I have, am I supposed to have 4?
They're both 48, right?
Am I
Alright,
supposed
so
to
you
get?
cut it once, what happened?
You need 2.
So you get 2.
Alright.
But now, am I supposed to write 3, or do I write 4? Because it would have been that would be
So,
in half.
This one,
Here's 2.
after each time you cut it, so you cut it
So it would be
once,
3.
so you would have this
So now I
one
have 3
here.
pieces.
Wait.
No,
Or is that supposed
I
to-
think
I
you're
think
trying to cut everything.
Yes, you're cutting everything.
It's 2
You're cutting everything,
tears.
I'm sorry.
2
Yeah.
tears, so 2
Yeah.
cuts, 1
You're
tear.
cutting,
Yeah, okay, that's
That's
good.
what I was thinking. If you're trying to model.
Yeah, so we cut both.
Yeah, 1 piece is the area of 1 centimeter.